Hi guys, today we are going to see about like an overview on the 3D printing. Because 3D printing is a growing technology now, is a current hot topic now in the manufacturing world. So in this video we are going to see about the 3D printing. What is 3D printing? It's just like a intro to the 3D printing. So what is 3D printing? What is 3D printing? What is 3D printing? So you can see over we can print some 3D objects instead of a printing. What is like printing? When you say that printing word, it means that it goes to some printer shops and get some xerox or printouts. They do it by means of ink. They print the ink on the paper, but we can't see as objects, right? Say some text on the paper, right? So that is printing. What if I say we can make it as a 3D printing can be done, so 3D objects can be done however you want, so with some constraints obviously. So let us look into what is happening in the inkjet printing. This is 2D printing which we see in the printer shops, some photo studios and all, where we get our passport size photos, printouts, xerox, etc. So how does it work? So it has so four ink tanks in the side of the printer. So where they have black color, pink color, and yellow, and one more color, I guess it's violet color, I guess. So they have four color. Yeah, it's blue actually. Yeah, sorry. So they have four colors that makes them. So the in the machine they mix means, I mean the machine, it's been mixed, and it will achieve the whatever the color we want, and it's been printed on a paper. You can see the statement over there here, ancient printers work by propelling microscopic droplets of ink onto the printing surface through tiny nozzles. The droplets are precisely controlled to create a images and text on the paper, providing high resolution. So the ink has a property to segregate, or you can say to divide into small droplets because of its viscosity on its surface tension. So we are making it some as an advantage, and making it as advantage using them in our application, in the way we make droplets of it, and we print it on the paper however we want. Okay, so we can see I have kept some uh, I have kept in this passport size pattern. The reason behind it is so to make to get a passport size, what is it, like simple process. Like they take photo, and they go to Photoshop, they edit it, and they take a some 6 by 4 inch photo size paper. They put some 8 photos into it. You see the size of each photo will be like height of 2 inch height, and width of 1.5 inch. So 8, you know that 8 so 8 photos will be sufficient in this space. So he make 8 photos, and then he send to the printer and print it. This is the process happening. He take photo, see the process, like take the photo, he upload into the computer or laptop. He just make a another put edit it, and he put in a one paper like 6 into 4 inch paper, and then he prints it. So so this is how this is happening in a inkjet printing that we see. So what is 3D printing? How, like, what is the difference from the 2D printing to inkjet printing? So in this we can make some 3D objects. 3D objects, yeah. So instead of 2D, it's like a not only for the papers. We can make some objects. We can make some objects out of it, whatever you want, based on our design. So basically, as mentioned, it's a additive process. Additive process, like a layer by layer process, or a particle by particle process. So how it's being done? It's not a some innovative thing and all. It's like a origin is from some G codes only. So we know that machining, there's a spelling mistake, so sorry for that. So similar to machining, so we machine the object. So what is the process? There is a, we will have some stock material which is a cuboid shape or bulk material. What we do, we just machine it off. I mean, we chip it off the unwanted the shape, in the shape, particular shape, to achieve a useful metal part or something else like that. Some application for something I can say. So there will be some application for that portion based on our requirement and all. So here I mentioned like follows the blueprint of the CAD. 3D printing follows the blueprint. Is like CAD is with the blueprint for the 3D printing actually. So what we do in normal subtractive manufacturing, you can see over here. Generally, we use subtractive manufacturing to make some objects like CNC machining, milling, this drilling process, and so on, so on, and on. So this where see, you can see over here in the image itself. You can see over here. You can see over here. You can, wait, sorry. You can see over here lot of wastage. Let suppose he's taking some bulk material like a stock material, he's machining, removing the material and getting into this shape. You can see lot of our chips, lot of wastage is over there. But if you see in this additive manufacturing process, he's achieving same thing, he's achieving same design with less wastage. So as a manufacturer, we should see that there should be less wastage to the less wastage, right? Is obviously we see for some good less wastage, and we should achieve the same design as well, manufacturing as well. So this is how this is the good advantage of the 3D printing. You can achieve a same designs, can be printed, can be manufactured with less wastage uh, compared to the subtractive manufacturing. So 3D printing. So like how many ways are there in the 3D printing? So it can be done by extruding some molten, let's say wire we have in FDM. There is a called fusion deposition model. Like suppose you might be heard about this 3D printing objects with plastic and all polymers. It's like polymers. So they use some PLA material, polylactic acid, this ABS and some PETG, and so on so on. So they'll use some material. They just heat it up. And extrude it through the nozzles. And you might be heard of this Creality uh, under the printers. You might be seeing this kind of printers. So they use some extrude the material. They take the raw material as a wire, and they been sent to the nozzles where we heat them. It converts into a little bit semi-solid kind of thing, and then it print on the shape what we require, and it moves the coordinates as given by the G code. So in 3D printing, it's like nothing but additive manufacturing. We call it as a additive manufacturing because addition of layers, as I mentioned previously. So it can be done by photo curing the liquid resin. So there are some resins which can be set up. I mean, it be hardened when it like exposed to the some UV rays, some photo polymerization we call. They just bond it up. The resin get particles get bonded up to form that shape. So and also powder bed fusion we call something like there is a powder particles, let's say metal particles are in powder form. What we do now, like we just put a laser heat source, give a heat source and just heat it up. So and it reaches some melting point we call like melting at high temperatures. At that time there is a property to the particles to bond it up. So that kind of approach we use. There are different approaches in different process in 3D printing, like not only the FDM. There are like curing as mentioned, like fusion, powder bed fusion, melting, deposition, DED, direct and deposition we call, and also even the rolling of sheets, like using some see ultrasonic laminations. I mentioned ultrasonic laminations, like the laminations of sheet metal is done by some ultrasonic vibrations. The ultrasonic vibration, you might be known that it's having some high frequency. It's vibrate with some high frequency, something I guess around 30 hertz, High frequency it vibrates and it's get the material gets stack up material gets stacked up. So if you ask me applications of 3D printing, mostly is for rapid prototyping, but nowadays they're using for actual manufacturing also, because as I see, if you see the suppose the traditional process, like we have machining, we forming and casting. When there is a complex shapes, we definitely should go to some casting and all, because we can't machine, we don't have that much freedom to for a machining tool to do that process in some time. We should go to casting and all. So there is a issue with injection molding, some particles, some parts from good surface finish. Okay, but injection molding and all, when compare, oh yeah, they go for some injection molding sometimes, silica molding sometimes, like that. But see, if you see their mold cost will be, as we know that mold cost will be high, so we can't go for a mold time every time, because suppose I want to do some new design, I don't know whether it will work or not, when a functionality will work or not. So what we do, so the mold concept is a very bad idea. So there comes this 3D printing. So 3D printing doesn't require any mold. So whatever design you just print it. So by this way you can see that it's a customizable product. So you can manufacture it like a customizable product. Suppose you want some design change, this design is not working in your first prototype, and second prototype you can make some design, just give it printed. That's not a big deal. And also in this 3D printing you can achieve intricate details, like very low scale, like a small scale details. It's like intricate details is like a small scale details, small features can be achieved with this 3D printing. This can be used by for 3D printing the rockets, houses. Rockets, they use some metal parts. Houses also now, even in India there is a company called Tosta. It's printing the houses with concrete. And also we can 3D print metal parts, we can 3D print bio implants, customizable. I want to highlight it, customizable bio implants. Bio implants, because there is a patient that requires, he requires some different design, he's and he will be some different orientation, the failure might be some different like failure of knee joint different from one person to another person, based on their problems and all. They can make a implants easily. Even for teeth implants they can make some designs. You can see printing cartography, something like, you can see some of the images over here. So as mentioned earlier, in additive manufacturing there are different types of process. So you can use liquid polymer, discrete particles, molten material, solid sheets, etc. SLA. So as I know that SLA is the first process is started by the 3D systems. Stereolithography, it uses resin. Uh, you can study detailedly over it. It will be interesting topic. All the different types of 3D printing process. Might be in future I'll make a videos on each and every process of the 3D printing, like different types of 3D printings and all. We can see over here based on a raw material. Raw material is like a input, maybe liquid form, maybe particle form, maybe molten material form, maybe solid sheets metal form. So based on this raw materials, based on this how they prints, like 1D channel or 2D channels, RF 1D channels, different types of printing capability. uh, Based on this it's been classified. So you can see over here all this LST, 3D printing, FDM, fusion deposit molding, solid scape, thermojet, this solid lamination and all. So, as I mentioned, even for a small inkjet printing, making a passport size photo, there is a small process called taking photo. You should take photo, upload to the computer. You need to convert into some JPG file, and you should give input to the printer and print it off. So here, so even for 3D printing also, or additive manufacturing also, there is a specific process to be followed. So initially we make design in some CAD software. we should save it as some STL file, and STL file we need to slice it up actually. So so let's say I took this as a object, this as a object. So the we should convert to STL file. What STL do, this will convert material into triangles, in a many number of triangles. Okay, the object is converted to triangles, so the coordinates will be there for the each and every triangle. So and we send it to, we save it as LT, will convert to triangles. Before giving to the mission, we convert it as some G code file, so we use some Cura software or Prusa software, where they convert STL file into G code file. What they do not just as we call it as a slicing. So what they do, they slice each and every layer based on your input of layer thickness. You just slice it off. So each layer will be, we can assume it as a text is printing on the paper. What if you stack up the text one upon one, one upon one, one upon one? It's converting to some 3D objects. It has X, Y, Z. So capability is 3D printing, machine setup, build. So build is like we are printing it off. So there is a, so here we can explain properly. So here, as I mentioned in the previously, there is a 6 by 4 inch paper, photo paper. So photo paper that should be like all the small photos should be fitted into this. Similar to this, the printers will have some bed size. Say let's say 230 cross for 300 mm, 230 cross 230 cross 230 mm, like that. Says based on the capacity, every printer has its own limits. Based on that, you need to slice it properly. Before slicing, you should know the what is its geometry and all, maximum it can print and all. So we build it on. So and also the build, for building there is a like two. So there are different types of like a layer addition, build plate addition we call it as, like skirt, brim and all. If you explore this Cura on Pirosha, you'll get to know about this. So where we have like, because say when we say building some houses and all, what we say, base is very important. Similar to this, so making a parts, base is very important, because it may, base is not a strong enough, the product may has good height, but it will may, it's like a cantilever, right, may just topple it off. So similar to this, we should take care of this build bed addition also. So remove it off, and post process and application. Post process maybe make the painting it and removing the support structures. We have support structures is like, suppose the metal is printing in an angle. So this is the build plate, this is printing somewhere like this, some angle. So always there will be limit, even for 3D printing there is a limit of it can't print in this orientation, because it doesn't have any supports on this side. Sometimes what we do, we just give a some support material with some less density, so to do this process. But after printing, we should remove this support structures and all. So that would becomes under post processing. Remove that part, that layers, that unwanted stiffeners, and we just paint it and use it for our application. I have mentioned some CAD software, SolidWorks, Fusion, the and CATIA, OnShape, etc. We can use it as a CAD software. We make the model, we convert into STL file. We give, we send further to slicing softwares like Crochet and Pro. We convert to STL G code file, and then we give input to the machine and just build it, and build, and mission parameters and all we can control in the slicing software itself. So this is the architecture of the some 3D printer, you can say this reality or whatever maybe. So it have actuators, sensors, temperature sensor, the mobility speed sensor, geometry like a level bit sensor, and all this platform control and all they will have. We have, this is the architecture of it. So you can see slicing system, support generation system, process setup, process monitor, like when what layer is printing now, which layer is getting printed now, whether it's going go fine or not, like fine or not and all, like this we should it should be like in visualization only, but it gives like which layer is printing, what is the weight of each layer, total weight, printing time, etc., etc., like this. So you were saying about 3D printing. If you ask me, like if you're saying about 3D printing, is it that much good? There won't be any disadvantages like that. If you ask me, so I can see there is advantage, simultaneously there will be disadvantages. So there are a lot of disadvantages, like under or under extrusion, that may be material lack of material, over extrusion like more material, holes, gaps, stringing, overheating, maybe where when you are heating it may be overheated because of some sensor issue and all. We can feel infill pattern decides the little bit strength of the material, gaps between infill and outline, curling, warpage, and etc., etc., etc. So these are defects will be there. So when there is a disadvantages, there will be definitely the disadvantages. So but we can just avoid them this kind of by proper controlling the this process, 3D printing process, like proper extrusion. Let's say under extrusion means some metal is lacking, we should give some proper material. Overheating means some sensor issues, or sensor might be not working, we should check up, inspect it, check the sensor, what is the issue, we can control it and do it. And curling and also in design we should take some measures. So before designing and all, this should be considered as a parameter. They should not we should not do this kind of design because it may something might happen while 3D printing. It may when we can, there may be a curling, warpage, something like that. We can so we can avoid them by uh, proper care, taking some proper care and all. So you can see over here, these are my first 3D printer parts. So which is printed by me using this SolidWorks software. I used as a CAD software and Cura software for slicing, and Creality for printing. These are the first parts. And thank you. Hope you learned something out of it. This is my overview on this. So I want to conclude with this, like a, so 3D printing is not a that much no, like completely new innovative thing and all. It's like came from G codes and all, as you know, we might be knowing about G codes and all. Similar to that only, but we can achieve wonderful thing, we can do wonderful things out of it, wonderful things out of it. Using 3D printing we can achieve, it's going to be a one of the thing in the industry 4.4 and 4.0 and all.